So again, I'm going to give you the formulas if y'all would like to see me verify the proofs of these formulas. I would be happy to do so. Just let me know it and I will. But for right now, we're just going to go ahead and give the reduction formulas. And again, these are on your formula sheet. So the first one is the sine squared of theta is equal to 1 minus the cosine of 2 theta over 2. And the way that we got this was just using the cosine of 2 theta formula and solving for sine squared of theta. So that's the first one. Then I have the cosine squared of theta is equal to 1 plus the cosine of 2 theta over 2. And again, on this one, all I'm doing is I'm using the formula for the third formula for the cosine of 2 theta, and I'm solving it for cosine squared. And then tangent squared of theta is just sine squared of theta over cosine squared of theta, and the 2's are going to cancel if you keep change flip. So this becomes 1 minus the cosine of 2 theta divided by 1 plus the cosine of 2 theta. And so these are your reduction formulas. And you do have these formulas on your formula sheet. Make sure you look for them and see where they are so that you can use them when we get to the test or when you're doing your homework. Now, let's look at a problem that we would want to use these reduction formulas on. So this one says, write an equivalent expression for cosine to the 4th of x that does not involve any powers of sine or cosine greater than 1. So what we want to do is notice we're trying to reduce, that's what it's called, a reduction formula. We're trying to reduce our exponent. So the first thing that I'm going to do is I'm going to say this is the cosine squared of x squared. Okay, because when you square and then square again, that means cosine of x times cosine squared of x times cosine squared of x. Or if you would prefer, we could also do it as cosine squared of x times cosine squared of x. And remember, you add your exponents. 2 here plus 2 more here gives me 4 altogether. Now, what is the formula for the cosine squared of x? Well, it is 1 plus cosine of 2 at theta over 2. And the same thing here. 1 plus cosine of 2 theta, or I guess I should say x, 2x over 2. All right, so if I FOIL out my numerator, 1 times 1 is 1, plus 1 times cosine of 2x is cosine of 2x, plus cosine of 2x times 1 is cosine of 2x, plus cosine of 2x times cosine of 2x is cosine of 2x squared. And that would all be over 2 times 2 is 4. So all I'm doing is I'm FOILing it out. I use my formula and then I FOIL it out. So this gives me 1 plus, and then I have like terms here. Cosine of 2x plus cosine of 2x is 2. We're adding them. 2 cosine of 2x divided by 4. Now, let's go ahead and split this into 4 separate fractions, because notice that I still have a cosine squared of 2x. So they don't want any powers. They want it all in terms of just cosine x or sine x or tangent of x. In this case, it'll be all in terms of cosine of x. So this would be 1/4 plus 2 cosine of 2x over 4 plus cosine squared of 2x over 4. So I'm going to go ahead and cancel this. So I have 1/4 plus 1/2 cosine of 2x plus, and I'll write that as 1/4 cosine squared of 2x. So now the last thing that I have to do is I now have to use my power reduction formula again to get rid of the cosine squared of 2x. Now let's let u equal to 2x. So I'm going to have one-fourth cosine squared of u. So using my power reduction formula up here for cosine squared of theta, this would be, copy down all of this, one plus cosine of 2u over 2. And so now I have no more squared because I've used the power reduction formula to reduce this from a square to just a cosine squared of theta to a cosine of 2 theta. And so now let me go ahead and simplify this a little bit, and I also have to resubstitute. So this would be 1/4 plus 1/2 cosine of 2x plus, and I'm going to go ahead and multiply my numerator here, 1 over 8, and it would be 1 plus the cosine, and instead of writing it as 2u, let's see what 2u is equal to. So 2u would be equal to, if I multiply both sides of the equation by 2, that would be equal to 4x. So this would be 4x. Now, if you do not like to use a substitution, you don't have to. I just like to do it because I think it simplifies things when you're working with complicated formulas. So now I'm going to distribute the 1/8 to have 1/4 plus 1/2 cosine of 2x plus 1/8 times 1 is 1/8 plus 1/8 times cosine of 4x is 1/8 cosine of 4x. And now I can combine my 1/4 with my 1/8. My common denominator is 8. So to make the 4 into an 8, I need to multiply it by 2. So whatever I do to the denominator, I have to do to the numerator. So multiply numerator and denominator by 2. So this gives me 2/8 plus 1/8 gives me 3/8. So now I have everything simplified, and notice there's no powers of the cosine of x. So this is how you would use this power reduction formula. Now let's do one more of these. Problem number 2. This would be something that you would use usually not until second calculus, if you take calculus twice, first and second calculus, but it is something that I wanted to show you so that you will have seen it before. So if I have sine cubed of 2x, and I want to use the power reducing formulas to show that this is equal to 1/2 times the sine of 2x times 1 minus cosine x. All right? So, this is going to be, let's work on this side of the equation. So what I'm going to do is I'm going to split sine cubed of 2x up into sine of 2x times sine squared of 2x. So here I have a sine squared of 2x. So I'm going to use the power reducing formula. For the sine squared of 2x. Now again, or the sine squared of theta. Now again, I'm going to let u equal 2x. So this is going to be sine squared of u. So using the formula now, it's going to be 1 minus, oh, I'm sorry, this should be a 4. I copied the problem down wrong. 1 minus the cosine of 2u over 2. Right? So now resubstituting, if I have 2u multiplying both sides of this equation up here by 2, that would give me 4x. So this would be sine of 2x times 1 minus the cosine of 4x over 2. And now notice the only thing that I have to do now is bring out the 1/2. And so this would be 1/2 times the sine of 2x times 1 minus the cosine of 4x. Now they do have these extra parentheses, but remember we can multiply in any order that we want. So I can put the brackets around anything that I want. I could put it around these two factors, or I could put it around these two factors, but this is what they wanted. So I'll put it around those two factors. And then we have verified that identity. So that is how you use the power reducing formulas to simplify things, to work with anything that has a high power of either sine to the 4th of x, or sine cubed of x, or sine cosine cubed, or cosine to the 4th of x. And you can use those formulas to do the to reduce that power. So this is the end of part 3. I'll start part 4 in a second.